There we go. Okay, but before we start with the technical parts, first some updates. So remember that the deadline for assignment 3 is today. I hope things are going well. There seems to be a lively discussion on Piazza. Yeah, if you have any problems, just ask on Piazza and we make sure that everything works fine. So just remember to push your solutions on GitHub before midnight tonight. Then assignment 4 is published now. So this is the first assignment that is slightly different to the assignments before. So this time you will have 3 weeks to do the assignments. It will also be significantly larger. So you will get 30 points for 3331 and 40 points for 4331. And then after these 3 weeks, so it's the same procedure, you hand them into GitHub. And then we will have an additional week where we do a peer review. Right? And so then you will actually look at another of your colleagues' solution and suggest improvements on how she or he can improve their solution. So that will be, but that we have still 3 more weeks. And then topic of assignment 4 is numerical Python, so particular NumPy, and how we can even integrate C programs with Python. So we can have a quick look at the assignment. So the assignment will all be about computing integrals. So computing the area underneath the function and how we can do this not analytically but actually numerically on the computer. And there's a mathematical background, and so we will adopt again a test first, then write your code approach. So you first have to write the tests, and then later on you write the implementation. So you see there's one exercise that's just for in 4331. So if you're in 3331, then you can just ignore that. And there's also bonus points. So if you feel like you want to earn some extra points, you can do this exercise, the last one. And there will be also a contest. So we will hand out, you will have to compute the integrals of fairly long, seemingly complex equations. And whoever can do that the most accurate will win a prize. So if you're up for a challenge, go ahead. Then one last thing about the group sessions. So group 6 has been cancelled. I already announced that on the webpage. Group 6 was also the only one which was in a computer lab. So for that reason, we now moved the group 2 into a computer lab. So if you would like to work on a EFI computer system, then please visit now. And you were in group 6 before, then just move to group 2 now. And otherwise, you can just, if you were in group 6, just choose another group that is convenient for you. So I think you're flexible enough and that you can just choose what is best for you. Any questions? No? Let's start. Oh yeah, before we start, overview over the next few weeks. So today is, again, the second part of the Python basics. Next week, I'll give you an introduction to NumPy and Matplotlib. Then I'll have your lecture on mixed programming and how we can mix C programs and Python programs, which is a very important topic and also a topic of the exercise. And then actually after that, we will have a guest lecture by Benjamin Ragan-Kelly, who will talk about the Ipython Notebook. So this is actually the system that I'm using here in how I'm also presenting, and when you see that I'm executing code live. That's the Ipython Notebook. And Benjamin Kelly is actually here. Would you mind standing up? Yeah, so he's, he doesn't want to. But he's one of the core developers of the Ipython Notebook. So, and he will tell you a little bit about the project itself and how Ipython works, and maybe something else that we haven't discussed yet. So we'll see. Good. Okay, so let's talk about a little bit more about the classes. I gave you a very quick introduction last week, but there's many topics that I haven't touched on yet. So one thing that people often ask, and that also came up on Piazza, I think, is what is the self variable that shows up in the classes? So if you remember, if you look at a very simple class implementation, so let's say we want to have a car, and the car has an init function, it takes a color, and then it also takes the self variable here. And then we use the self variable here to attach the color to the object instance. The same thing happens here when we define a start function, and again the first variable is the self variable. But then strangely, when we actually create a car, then we only provide the color. We don't need to pass in the self variable. So what's going on here? So the role of the self variable is that it's actually a magic variable. It's the instance object that Python automatically passes to the class instance method as its first argument when called. So in simple words, what this means is when you call car.start brackets, that's actually equivalent to calling, so be careful here that I'm using the instance, I'm using one specific instance of the car. That's the same than calling car.start, and now I'm using the class method, and passing in the instance as a first argument. Okay, so these two things are equivalent, and you could almost say that the first example here is just a shortcut of the second one. So the second one is very explicit, right? So I call car.start, and start takes an first argument here, and what I pass in here is the car instance. And then if you think about this notation here, then it also makes sense that you can do things like print self.sound, because then self here represents the car instance, and the car instance has a sound member that we've attached here. Okay, so this first argument is really something that Python magically removes or attaches really when you call a class function. So just so that you're aware of that. So another note here is that the name self is arbitrary. So there's no. In principle, you could call these the first variables here in the class differently, and in some cases that might be a good idea. But in most cases, self is kind of the industry norm. So if you don't have good reasons, then just always call the first variable in a class function self. So why do we have this self in the first place? Well, the reason is because if in a function we want to access attributes of the instance itself. So if we want to print out the sound that a car makes, that a specific car makes, then we can use the self.sound to access that. Okay, so the next thing that I haven't mentioned yet is subclassing. So, in fact, in Python, Python has the concept of subclasses and inheritance, and the concept is actually fairly similar to what we have in Java and C++. Except, so if you're familiar with the class system in Java and C++, and you switch to Python, but you need to remember that all functions are virtual. Then there's nothing like private and protected variables, even though we can simulate that behavior, and I'll show that to you in a second. And essentially, with these two main differences, the result is that class programming becomes much more approachable and easier and faster than what we have in C++ and Java. Also, in Python, you can actually use single and multiple inheritance, and I'll show that to you now. So let's say, so these inheritance or subclasses, the reason why we have them is because sometimes it's useful to create a class that inherits all the functions of an already existing class. Right? And so the reason why you might want that is because you want to have a specialized class. So for example, let's say we created this car class that when we created a function that can start the car and so on and so forth. And now we want to implement a specialization. Let's say we want to implement a golf car, right? So golf is a special car. But we don't want to re-implement all the functions that we've already written in the car class. So instead what we will do is we will inherit, we will make golf, the golf class inherit from the car class. And by doing so, golf automatically gets all the member functions and on all the attributes from the car class. So the way we do that is and so the first line when we define the class, in these brackets we always had this keyword object before. And so now we just replace it with the class that we want to inherit from. So in this case from car. And then in the constructor function, we should also call the constructor of the car class. And so essentially the way I do that is I just call car.init, and then I pass in the instance and the color. And so this call here matches exactly to the definition of the constructor of the car class. So essentially what's going on in this line is that we call the constructor of the base class car, and the base class car automatically attaches the self.color and self.sound. So if we go back to the implementation of the car, so here it's this function here that we're calling, and so then automatically we will, after calling this, our golf class will also have a color and a sound attached to it. And so then, after that, we can start specializing our car, right? So we can, for example, change the sound to differentiate. If I wouldn't do anything else, right, then these two classes would behave exactly the same. But now I can specialize it. And for example, I can change the sound now to say golf roar. Right. So now if you try this out, so now I can create a new golf car and I can start it. And if I do that, then I indeed get the specific sound that a golf makes, and not just a general car. So now we can also have additional functions that we can add to a car. So you might know that some of the golfs they were cheating, right? And so let's say we want to have a diesel golf, and so then if we wanted to kind of re-implement the cheating process, then we can attach a specific function to that car. So for example, we could just add the function cheat, and then that function would change the sound of the car again, right? So you obviously shouldn't do that, but it's just to represent what classes allow you to do. So now this diesel golf is a very special car, right? So it actually inherits from the golf car, and the golf car inherits from the general car. So now I can create a new diesel golf. I can call the cheat function, and I can start it, and then it behaves very quietly. Okay, so for you to remember, so you can use these class inheritance to make specialized version of already existing classes. So now you might want to ask, okay, so what was the when we created the car object, the car class, we actually also inherited. We used the same notation here, and we inherited from this object class here. And an object is something that is provided by Python, and it's essentially the mother class. So any class in Python is automatically inherited from object. And we can, so object is a class, is a specific class, and we can check which functions this class implements. And so when you call dir, so dir is a Python specific function that you can call on any object. And so if you run this, Python tells us which functions and members this class has implemented. And you can see there's a bunch of, so this is just a class of functions here that we have available. And the interesting part is that, for example, the object class implements string, right? And so that certainly explains why things like this work, where we can write string of car, and we get kind of string representation of a car. And what's going on here is that, so I haven't implemented the string function for car, but because I'm inheriting from object, right, Python checks if my car class has a string method implemented, finds no, there is no string method. So then it will fall back to the object's string implementation, right? And then it will call that. So what you see here, that's the output of the object's string representation. And so the same thing is, for the same reason, things like these work, where you can compare two class instances. And so then what you're calling is this equal. It's a magic function, right? And so essentially you're calling the equal function. Yeah?
So if you compare two instances, is it comparing the address or like the attributes of the?
So no, it's comparing the addresses. So if you made two cars that both have the same, right? So if you just look at the attributes, they're exactly the same, the two cars, but they're two different instances. If you wanted to have your own comparison, right, and maybe you want to compare only by the attributes, then you could overload the equal function in your class. And then this function would behave differently, right? But the default behavior is that it compares the instance itself. So one comment on object orientation and how Python differs to C++ and Java, for example. So let's say we create this a function that starts, that calls the start function on, that basically starts an object. So what the function looks like, it takes in an object, and then we call then we call the start function on that object. And so now what I can do is I can call this function start and pass in, for example, a car, right? And then I would make this sound. But I could also pass in the golf, for example, and then it would call the start method of the golf. So the reason why this is so special, because it's not so easy to achieve the same thing in Java. So in Java, you would actually in the function definition, you would have to declare this variable v here as a car reference, and then rely on the fact that the golf has a virtual function start, so that the correct start method is being called. In Python, we don't need that, because Python will just call the start, as long as in this function definition here, whatever we pass in, as long as this object has a start method, it will just be called, right? So there's no checking if a variable is of a specific type or not. Python doesn't care. It just checks, does this object has a start method, and if yes, then we call it. If you pass in something, if you try and run this on something that doesn't have a start method, then you will get an error message. Right? So essentially, this method works for anything. This method works for anything that has a start method. Sometimes it's useful to test if you're working with an object. Sometimes it's useful to check which type this object has, or the type, the underlying class. So one example could be you're writing a function and you want to make sure that what you get in that function is a numerical value, like a floating point value, right? So maybe you're trying to compute some integrals, and you want to do some error checking that the user didn't accidentally pass in a string. So one way you do that is you use the isInstance function for that. And the way it works is that you pass in the object that you want to test, and then the class that you want to test against. So if that line here evaluates to true, then in the if statement we know that object is indeed a car instance. We can also do, there's also the equivalent for subclasses, so we can check if a class is a subclass of another class. So you could ask if is subclass golf car, right? And then you would test if golf is a subclass of car. If you want to test if you have two objects and you want to test if they have the same class, you can do an if statement where you can use the magic function __class __ that extracts the class from that object, and then you can compare these two classes. All right, let's talk about private and not public data. So I already mentioned that in Python there's no differentiation between private and public data. So in principle, if you have an instance like a car, you can change that instance just like you want. So here's an example. I take the car and I actually overwrite the function start. I replace that function start with something else. So the lambda this lambda notation here is one line. It's a short notation for creating functions. So this just means that the right-hand side here is a function that takes no arguments and prints out something. So what I'm doing here is I'm taking a car instance and I'm replacing how it behaves, but just for that instance. So if I run this, now suddenly this specific car behaves differently, right, because I replaced the start function. So there's no technical reason on how to prevent this from the user. Python doesn't allow, just always allows changing of class attributes. But there are some conventions that you should use. So sometimes it is obviously useful to hide certain details from the user, right? So maybe you have a very, very complicated class. There's loads of difficult member functions that the user doesn't really care about. So ideally, you would like to hide it from him or her, that it becomes easier to use. And the way you do that is by conventions. So if you want to have a non-public variable, you should start that variable with one underscore. So then Python treats it as a non-public variable. If you start a variable with a double underscore, then it's considered strictly private. And strictly private means that actually there is no direct way of accessing that variable anymore, because Python will mangle with the names. So if you create a variable that starts with double underscore, for example, __ sum, then actually if you want to access it later on, this won't exist anymore, but instead you have to call it underscore, then the name of the class, and then __ sum. So this is a way on how Python hides it a little bit, but if you know what you're doing, then you can still access it. And then there are these functions and methods that start and end with a double underscore, and these are special methods and attributes. And I talk about them a bit more later, but you actually use them already in your exercise, right? So this is in your polynomial, you implemented all these special functions, and you already learned how they behave. So here's an example. It's a class, and we have this self.a variable. So that's a public variable, and it's easily accessible. Then we have this _b variable. So these are non-public variables. And then there's the __ c variable that is a private variable. And the same thing you can also do with functions, right? So you can call a function with double score. Now, if you would like to use that, so we create a new instance of my class. So I can just write m.a, that gives me the normal, because it's a public variable, then m._b to get the non-public one. But then if I want to get these strictly private variables and functions, I have to change the name here, right? So I have to add this class name. Otherwise, it wouldn't work. Yeah. And so normally also if you use some smart editor, and you do kind of ask for code completion, it will actually normally hide these strictly private ones. Or maybe you have to press double tap to get the full list, right? Or maybe sometimes even the non-public ones. So your editor is trying to, it normally follows these conventions and helps you a little bit to keep the structure clean. So then we have special attributes. So these are these functions that always start with double underscore and end with double underscore. So I can use the dir function again to list all of them, and you see there's a bunch of them are already implemented. And so I want to show you another example, a specific example one, and how it can be used. So let's inspect one of them. There's in particular this dict thing. So if we look here, oh no, it's so yeah, here we go. So let's for example look at what that does. So let's get the dict special attribute of the golf, and that's what it returns. And if you think about it for a second, so what this means, what you get here is all the member variables of that instance, right? So we get the color and the sound that it makes. So in other words, it returns a dictionary of the user-defined attributes of that instance. So if you want, for example, if you have a class instance and you want to programmatically check which member functions, which member attributes it has, right? You can do that by using this dict special attribute. There's other ones. You can get the name of the class. So if you have an instance and you're interested in what is the underlying class, you can use the underscore class underscore. And then again, if you're interested in the name of the class, you can use the special member of a class object, which is just underscore name underscore. So here you need to remember that in Python actually everything is an object. And so what works on a golf also works on a class, right? So here I'm asking for a special attribute of a class, right? And that works just the same as asking for a special attribute for the golf. Then there are these special methods that we already used for our exercise. The special methods are called in certain situations. So if you're trying to convert an object to a string, then Python will try to call the underscore string method. The same thing is called when you're trying to print out an object. Then another one that I'm going to explain to you a bit more in a second is the call method. And so the call method is used if you're trying to use a class instance, but and use the normal bracket notation here, right? So you're almost trying to. This almost looks like A is a function, and you're calling that function with two arguments. But if A is a function, then that's what happens. But if A is a class instance, right, then Python will try to call the underscore call underscore method. And I'll show you to you in a second why that might be useful. And then the comparison operator. So if you're trying to compare two things, in order to perform this comparison, Python calls the underscore equal underscore method. And so that was a question just now when you want to compare two classes and you want to have your own comparison. You want to implement your own way on how to compare two class instances. What you need to do is you need to implement your own underscore underscore EQ underscore underscore method. So I'll show you an example on how this can be useful. Like a practical example. Let's say we have a function, we implement a function f. It takes in 5 parameters, x, y, and abc, and then it does some numerical computations. And then we would like to send this function into another function. So this other function is called grid values. It takes in a function and then some x coordinates, some y coordinates, and a file. And essentially what I'm doing is I loop over, so where this example comes from is from simulations, from numerical simulations. And we have a domain with x and y coordinates with loads of points. It's a grid. And I would like to evaluate that function on each grid point and write out the result to file. So then what I'm doing is I loop over all these x coordinates and y coordinates. Then I call that function on these specific coordinates, and I write out the file. Okay? So everything, that looks fine so far. Now the problem is that my grid values function, someone else has written, and he has written in such a way that f is only supposed to take in the x and y values, but my implementation actually takes x, y, and a, b, c, right? So at the moment they're incompatible, and the question is how can we send f into this function grid value? Okay, so the first thing that we could think of is we could say, let's use some global variables. Let's just make a, b, and c global, and then in the function definition here, x and y, Python will actually just use the global values a and the global value b and the global value c here, right? And so now I've changed my function definition f such that it only takes 2 arguments, and I can down here I can specify which values I want to have for a, b, and c, and so then I can pass it to grid values and things will work. The problem is global variables are really evil. So we shouldn't use them until there's a really good reason. And the reason is because it gets really messy if you start introducing loads of global variables. You end up not knowing anymore what's happening. Maybe you suddenly start using 2 global variables with the same name, and then you change one, and then obviously you also change the other one without realizing. So we need to find a better solution for this. So the second solution would be, well, maybe instead of introducing global variables, let's just use default values. Right? So we can make our function f more flexible so that we can call it with a different number of keywords. And so let's just assign default values to a, b, and c. And so after we've done that, then we can call grid values again with just 2 parameters. And otherwise, we will just use the default values if we don't pass them in. So the problem with that is that we now fixed ourselves to using one specific set of default values. Right? So what if I want to call grid values now with a equals 1.5? Right? So then I'm stuck again. So that's again not exactly what we want to have. So the solution is, of course, to use special classes. That's why I've introduced them. So at least one solution would be to make a class and implement the call operator. And so essentially what we're going to do is we're making this function f, and we wrap it into a class, and we implement the call attribute so that the class behaves just like as if it was a function. So this is what it looks like. So now we have a class capital F, we implemented a constructor, and the constructor takes A, B, and C. And so when I'm constructing this class, that's where I specify what the values of A, B, and C should be. Right? I can have some default values, but I can also override them if I want. And then I implement the call method, and I implement the call method such that it takes exactly 2 arguments, namely x and y. And then the call method performs the maths that I had before. So now I'm using self.a to get the value of a of that class instance, self.b, and self.c. So now, how would I use that? Well, first I create an instant of that class, and I specify the values that I would like. So I say f equals capital F, a equals 0.5, and c equals 0.01. And so now, after that, I can use f just as if it was a function. So I can call f equals f bracket 0.1 and 2, and then I would get the return value out. Which means that I can pass it into I can pass it into could values, and it will do exactly what I want. So essentially, what I've done here is I've changed. I created a class whose instances behave just like normal functions, but I have more flexibility. Is that clear? Yeah. Okay. So another thing that is sometimes useful is to have class variables. And these are variables that are static to all class instances. So far, all the variables that we've used, their values, they were specific to one instance, right? So the one car was green, and the other one was blue, and the next car was red, and so on. But there was nothing shared between the cars. So class variables, or static, they're sometimes called static data, these are variables that are shared between all class instances. So one usage of that is, let's say you have a point, you're creating a point class, a class that represents 2 points in 2D, but you would like to count how many points you've already created. Right? So that counter is something that is not instance specific, but it's something that you kind of need to have one global tracker for that class that keeps track on how many points you've already have. And the way you do that is you create create these variables outside the function definition and without a self. Right? So you just say counter equals 0, right? And outside the function, outside the constructor here, for example, and that makes a class variable. And then in the constructor, let's say, where I take in the x and y values, then I can do instance-specific. I can assign instance-specific variables like the x and y values. So these are specific to one point. But I can also use now point.counter plus equals 1, right? And by using, so remember here self was the instance, but now here point, so here I'm using the class name. So I'm using point.counter to access the static variable counter and increment it by 1. So now let's test this. So I initialize now the class, and let's say I create now 1,000 points, all with different x and y values. So let's do that. And now I can check how many points I've created. So I can, the way I do that now is I call point.counter, right? So here now I use the class name because it's general to the class. It's not specific to one instance, but general to the class. So I can just ask the class, what is your pointer value? And then it will tell me, okay, you've created 1,000 points so far. Yeah?
Is it possible to access the other 999 point class, or are they just discarded as soon as you make a new one on the same variable?
Right. So the question is, in this example now, I create 1,000 points all with the name P, can I still access the 999 that I've created previously, because I'm overwriting this, I'm using the same variable. And so the answer is no. So here they're lost. After this loop, so this is kind of a pointless loop. Well, except this is almost a pointless loop, except that I have this global counter. Right? But so if you wanted to keep all the points, right, you would create a list and store them all in a list. That's what. So yeah, this is not a very useful example. I agree. So yeah, you should definitely create a list and store all these points in a list. So you can also, the same thing actually also works for instances. So the counter, the static data is not just available through the class, but also if you have one specific point and you ask it the counter value, then you also get the 1000 out. Static methods work essentially the same. So you remember what we just said so far was just static variables, but the same thing works for methods as well. And the only difference when you define static methods is that you don't declare you don't need to pass in the self argument now, right? Because a static method is not specific to an instance, but it's general to the class. So now in the function definition, we don't need to have the self method. And then inside that function, we can only access static data, right? So in that function, it doesn't make sense now to write print self.x because the static data is not instance specific. So for example, in here, I could return point._counter because _counter is a static data. But so far, Python doesn't actually know yet that what you've defined here is a static method. So there's this, a command that makes a function, a class function, a static function, and that command is called static method. So what you say here is you say n copies. So this is almost like essentially the static method function makes a function a specific static function, right? So I'm using static method here. I pass in the n copies function that I've implemented, and then I return, and then I store that result as static data to my class. Okay, just like I stored the counter variable here as static data, I now store a function as static data to the class. So now, if I execute this, now I have a n copies function that I can call not on the class on the class instance, but actually on the class itself. And what happens now is that this n copies is the static data here, and it knows, okay, it's a static method that actually points to underscore n copies. So it will call this function up here. And the same thing, also static methods are also available for instances. So let's say at the beginning I didn't have any point, so I created a new class. So that's why we lost the data from before. And then let's say I make one specific point, and I ask the instance on, well, how many other points are out there, then you get the one out. Yeah?
Why do you need point in it? Just do the underscore counter?
So if you did this, then let me see. So I'm actually not entirely sure what happens. Let me just make this a bit simpler. And let's just say underscore counter equals 1 here. Okay? So this comes, what happens now is that Python will create a local variable that is called underscore counter that is only available within the init function. Let's just, before I say something wrong here, can we just try this out? Yeah. So see, the init function sets the underscore counter to 1, but this is actually a new variable that lives only within the init function, right? So if you don't add point dot to the end to here, then you're just changing, you're creating just a local variable, set it to 1, but as soon as you leave the constructor, that variable disappears again, right? So for that reason, you need you need to say specifically, I'm interested in the static data of the point class and change that. So I'll actually talk about I'll talk about the scoping of variables just in a few minutes. Are there any questions? No? Let's have a break.